We all know digital computers only know ones and zeros or binary. But interestingly, computers can represent anything we want using only those two digits. You want to know how? Well, stick around and I will tell you. So let's take the problem at hand. Let's say you want to save an image to your computer. An image contains a lot of color details, but your computer only knows ones and zeros. So how do you convert all the details of an image to series of ones and zeros? Also, when you want to view the image, how do you reconstruct the image from the saved binary data? So your operating system must be doing some magic in the background to convert images to and from binary data. Okay, now you know the general problem. Let's try to make it a bit more simpler so we can wrap our heads around this. This is not a problem only your operating system has. Operating system is a one big program that runs in your computer. Just like your operating system, any program that you write has to be able to convert to and from binary data. To illustrate this, let's get a computer, but not everything, just the two most important components, which are the CPU and the memory. And let's take a look at a very simple Python program. Programs have two components, data and some operations we apply on those data. Here we have one of each. When we run the program, we store the data in our memory and we run the operations on our CPU. In this case, it's a print statement to print some output into our terminal. So here we have the same problem again. How do we store hello world in our memory? Our memory doesn't know anything about English characters to store them. It only knows binary. The solution, as you might have guessed, is called a type system. Type system of a programming language has two responsibilities. First one, as we discussed, is conversion to and from binary data, also called serialization and deserialization. To convert decimal numbers to binary, you can use base conversion, as you might remember from high school maths. This is very easy, but to convert any other data like strings, you need some special conversion rules. There are universally standardized such rules, and the type system in your programming language knows all of these rules. In our example, to convert a string, type system uses a character encoding rule called Unicode. With Unicode, each character in your string is converted to a unique number which can be converted to binary. So using this rule, you can convert our hello world string to bunch of binary data. Since there are different rules for different types like strings, decimal numbers, images, etc., your program also needs to keep track of the type of this binary data chunk, because later on when you read this data, you need to know which rule to apply for the conversion back. This information about the type of this data is called a data type. So in our example, Python creates and saves hello world as string type data in binary format on the memory. Okay, now we know how to store and read different types of data from memory. Next, without using this data as is, you might also need to manipulate them. That's the second responsibility of a type system, defining rules for operations on different data types. Let's take an example of adding a whole number to a decimal number. It's a very easy thing for you to do using basic mathematics, but for a software program, it's a tiny bit complicated. First of all, we should know the type of these two data. That's easy enough. We discussed our programming language keeps track of these data types. Next, it needs to know addition operation is even possible and the rules behind adding a whole number to a decimal number. The rules are very simple. You just add the whole number part of the decimal number to the whole number while keeping the fractional part intact. No matter how simple this is, your type system has to know these rules. So that's the second responsibility of a type system, to know what operations are possible upon different data types and the rules behind applying those operations. With a type system that can handle these two responsibilities, any programming language you use can read, store, and manipulate data quite seamlessly. And that concludes what a type system is. I also want to go through the difference between a statically typed language and a dynamically typed language, because there's this misconception that a dynamically typed language like Python or JavaScript doesn't have data types or a type system. Python and JavaScript being dynamically typed languages has nothing to do with having a type system actually. They also have a type system and it has the same responsibilities that we talked about, similar to the type system in a statically typed language like C++ or Java. Do you remember I said that the programming language keep track of the type of the data? Well, how we keep track of this data type is what differs from a static typing to dynamic typing. To know the difference between static typing and dynamic typing, we first need to know what a variable is. Do you remember writing expressions like this in middle school math? Well, in this case, x and y are called variables. Variables are a label that you give on a certain chunk of data. Once you have assigned a variable to some data, you can use that variable name to access that data again from the memory. Again, do you remember that we need to know the data type when we read data from the memory? How you keep track of this data type is different between statically typed language and dynamically typed language. In a statically typed language, variables have a type and it is decided when the program is created. Most of the time, you as a programmer has to define this type. When you try to access or modify some data that a variable points to, we can use the type we define for the variable to do this. In a dynamically typed language, variables don't have a specific type defined to them. The type information is stored alongside the data itself, and your programming language has a way of checking that data type first, dynamically, and then use that data type to read the data. Now, you might be thinking, why do we have these two variants of programming languages? First of all, dynamically typed languages are very easy to use in a way because you as a programmer doesn't have to think about data types. I won't go into much details about why static typing is useful, but static type languages can do a lot of checks on variables even before the program is run. So they can check if you made a mistake like trying to do a sum up between an integer and some image data even before you run your program. Dynamically typed languages can't do that beforehand because they check the type dynamically when you run the program. Anyway, getting back to the topic, now you see that the dynamically typed languages and statically typed languages in fact has types. The type system actually is mandatory for any programming language. Okay, hope you now have a good understanding of what a type system of a programming language is and why it is used. You might also have a good idea what static typed and dynamic typed languages are and the fact that both of those languages need a type system regardless. Now when you go through a topic of data types in a specific programming language, you will know the underlying decisions and reasoning of why we have data types in the first place. So that's it for today. Subscribe to ByteXY, like the video if you liked it. Thank you so much for your time and see you back soon.